So as I was saying, you can easily find the voltage of the resistor alone, since the voltage of the resistor is equal in both, right? Since the battery and the resistors are in parallel, simply the voltage is gonna be 24 for the combination, which is equal for each resistor, right? Okay, so now 24 is equal to 10, again, since they gave it the resistance, I. So the current in each is gonna be 2.4. But now here we have the easier part, which is why I started with part B in the first place. Since here in A is 2.4 and in B, in resistor B, since it's identical to resistor A, it will have the same current, right? 2.4. And we know that in series, current is equal, yeah. So here we have the two resistors, and when we combine them, it's gonna be in parallel to C. But when we combine them, right, we're gonna need to add the voltage. So let's say we have here 2.4 and here 2.4. You see the arrows, right? And then they're all gonna go up to C. So this arrow is gonna be 2.4. This arrow is gonna be 2.4. 2.4 plus 2.4, 4.8. I had it way easier in my mind, but I couldn't figure out how to let it out, so I'm sorry for the poor explanation for this question. The force between two equal charges that are 2 centimeters apart is 1.2 millinewton. If the distance between the charges is decreased to 0.5 centimeter, the force between them becomes how much? So for this question, there's a rule for it, a really simple and nice rule, where so force 1, right? Force 1 over, no, other way around, sorry. So force 2 over force 1 is equal to x2, which is x1 squared, which is the distance, over x2 squared. And we're trying to find f2. And f1 is 1.2, so x over 1.2 is equal to x1 squared, which is 2 squared, or 4, over 0.5 squared, which is 0.25. You cross multiply and then you get that 19 is f2. Number 23 for the last and final question of today. 1.5 ohms ammeter can measure currents up to 200 milliamperes. In order for the ammeter to measure currents up to 10 ampere, the shunt resistor, okay. Normally ammeters are connected in series, but voltmeters are connected in parallel because voltage in parallel is equal and current in series is equal, whatever. But for the shunt resistor, it should be other way around to the device itself. So let's say we have an ammeter connected in series with the battery, for example, and we need to place the shunt resistor, and we'll place it parallel with the ammeter, not the battery, the ammeter. And then we'll do the same thing for the voltmeter. So we have the voltmeter parallel to these two resistors. and the shunt resistor for the what's it called, voltmeter, will be in series with the voltmeter. Okay, now we got that out of the way. Let's move on to part B, the resistance of the shunt resistor to 1 decimal place. Okay, look, the shunt resistance, which I'll call RS, is I full scale, right? Which in this case is the measured currents up to the amount it can measure up to. And then here we have I, which in order, like for the future you can say, minus I of full scale, which is, okay, times all of that times the resistance of the I'll just name it R. It's gonna be the resistance of something, but I forgot what it's called. Shunt resistor and that. Okay. Anyways, let's substitute 0.2 over 10 minus 0.2 times 1.5. You're gonna get something along the lines of 0.306. Wait, sorry, 0.0306, 0.0306. But then they want it in milliohms, so we multiply it by 1,000 and we'll get 30.6. Thank you guys so much for watching this video. We wish you guys the best of luck in all of your exams, especially in physics, chemistry, and everything in general. Anyways, peace out.